So this was the exercise from the last class, and what it says is take the second life model and perform a multi-group analysis with PLS-GUI using the 3-group 426 observations in the data file SL-426-EXP-3-groups.CSV. Are any of the direct effect path coefficients significantly different between any of the 3 pairs of group differences? Well, let's look at that first. So you can do this using either the desktop version of PLS-GUI or the web version. So let's use the web version. It's easier to access. It requires no software installed. You don't have to have R installed. You don't have to have anything but a browser. And there's a number of ways we could do this. The simplest way would be just to input the data directly. If you click here, anywhere in here, it should open up a Windows browser on your machine, and then all you have to do is drill down to the after class exercise folder from the previous day and point to the data set and say open. But then you have to upload it, push upload, and when you see all the data come out down here, you know that it's in there. So it shows the variables, the mean of the variables, the median, the min and the max, and the number of missing items, and there are no missing items in this data set. You also need a model. Right now we don't have a way to draw a model, but we're working on that. It will import just about anything from Smart PLS. It will import a model file, an SPLS-M file. It will also import from Smart PLS 2.0 the project file, SPLS-P, which contains both a model and a data set. And it will also import from 3.0 the project file, the .zip file. So we have a modeling file from 2.0 available in the exercise folder. So if you just click anywhere within that form, it will open up a browser and we'll go down. Here's the model, Second Life Splism. It's the SPLS-M file. So we open that, and you've got to upload it. And you know when you've done it successfully because it will run PLS automatically, and you know it's run PLS when suddenly you can see the path diagram. Okay, so we're good to go. This is an MGA, so you go over here to the MGA Analysis tab, and you have to tell it just a couple of things. You have to tell it the grouping variable, which is experience, and there are 3 levels of experience. Note that the property here for MGA analysis in PLS-GUI, it's a so-called N-level MGA, which means you can have as many levels to the grouping variable as you want. It can be 2 or 3 or 4 or 5, any number, and it will find all of the pairwise differences between the group, those levels. For example, if you had 2 groups, you get the pairwise differences on 7 different parameters, and you get 7 different reports if you have 2 levels or 2 groups. If you have 3 groups, then it's going to do a pairwise on group 1 versus group 2, group 1 versus group 3, and group 2 versus group 3. So you get 3 different sets of pairwise differences with 3 levels, and you get 7 different reports, or that is, it shows you the differences, the pairwise differences between 7 sets of parameters. So you get 21 reports if you have 3 levels. If you have 4, I think there are 10. I believe there are 10 pairwise combinations. So you end up with 70 reports. That is 70 reports There are only 7 per pair, but of course if you have 10 different pairwise, you get 10 times 7. Okay, so anyway, tell it the grouping variable. It's going to run PLS over and over again in performing a percentile bootstrap, percentile permutation bootstrap, and you can have any number of permutation resamples up to 10,000, which is plenty. 5,000 really is pretty much the gold standard, the limit, the upper end on the gold standard. A percentile permutation, what it does is, briefly, if you're looking at the difference between two groups for, let's say, a particular path coefficient, it will estimate the difference between those two path coefficients in your set, your original set, and that will be the test statistic, that the magnitude of that difference. So let's say one path coefficient is 0.4 and the other one is 0.3. The difference between them is 0.1. But the question becomes, is that difference, 0.1, significantly different from 0 at a 95% confidence level? How can you tell that? How can you determine whether the difference between the parameter for the two groups is significantly different from 0? That's really the issue. And in the past, the way this has been done, both with PLS and in general, is to use a parametric approach where you have a ratio, which is essentially the test statistic in the numerator and then some measure of the pooled variance in the denominator, which yields a t-like t-distribution. So you're looking for a number greater than or lesser than 1.96 to indicate significance, two-tailed test at 95%. The problem with that is that PLS is not parametric. PLS dismisses the distributional assumptions that are required for parametric tests of that nature. And in addition to just that one assumption, to use that test, there are a couple of versions of that parametric test. One is called Satterwhite. The other one, I believe, is pooled variances. There are other assumptions as well. The groups have to be about the same size. They have to be approximately normal. There are some other ones. And it is rather difficult actually to establish them. Another approach, there are permutation approaches, and we use a permutation percentile approach, and the way that works is it takes your test statistic and it's of a certain magnitude, say 0.10. What you do is, let's say you have 1,000 observations, 400 are in one group and 600 in the other. It will randomly take your entire data set of 1,000 and randomly choose 400 of them and randomly assign them to one group and take the remaining 600 and assign them to another group, and then run PLS on each group and compute the difference in the parameter and record that amount. And then it will put them all back together once again and again randomly select 400 of the original set of 1,000 and assign them to group 1, take the remaining 600, assign them to group 2, run PLS again and estimate the difference based on that random assignment of the original observations into the two groups. And it'll do this, say, 5,000 times, computing the difference each time. And what happens is the difference will change each time. It'll be various numbers, but with the random assignment, a distribution will emerge. A density function will emerge of all of those different computed differences from the random assignments, and that density function will pretty much have a mean of 0. But with the percentile permutation, all you do is you take your original test statistic, 0.10, and you just count how many are lower and how many are higher. And you assign a significance level based on the relative position of your test statistic in the entire percentile distribution. It doesn't matter what the shape of it looks like, although it will be normal. It's an absolute count. So if you do it 5,000 times, you get 5,000 different values, and you put your test value into that range and determine whether 95% of them are lesser or 95% are greater, in which case you know it's significant. So let's continue this. So we can scale it. Good idea to scale it. And we'll just go with 100, and we don't have to worry about the rest of this stuff. And then we'll just say start. And we get a little progress bar. Note it does, because we have 3 groups, it's actually doing this task 3 times. It's doing, instead of just comparing 1 pair, it's comparing 3 pairs. Group 1 and 2, group 2 and 3, group 1 and 3. And we recently implemented this progress bar, so you can tell what's going on, which is helpful. Is helpful if you are wondering if it's still running or not. And I'll tell you something about PLS-GUI, about the web version here. If you don't get an error message, it's still running, if that's comforting. But these progress bars definitely help because you can visually see what's going on. So it'll get to the end here, and then it will produce 7 reports for each of the 3 pairs. And the question in the exercise was actually about the significance. So let's let this finish here. Okay, so there we have these groups. The question was, are any of the direct effect path coefficients significantly different between any of the 3 pairs of group differences? So let's look. So there's direct paths 1 and 2, and sure enough, the path from enjoyment to attitude and the path from trust to attitude are both significantly different. Extremely, actually. Ours was, there were 100 that were lower, and here there were 100 that were higher. No, the other way around. Here there were 100 the other way around. A 1 indicates that the difference was the highest, that there were 100 lower. And a score of 100, I'm sorry, I'm looking at the wrong thing. Here's the difference, minus. This one is minus, so 100 were higher. It is. It's the number that are higher than your test statistic. We had a very big difference, a negative difference. And we resampled 100 times, and they were all higher than this large negative difference. This one, which is significant, this is the first group estimate. There's the second group estimate. There's the global estimate. This is the difference. This is way more than 0. Way more than 0. In fact, all 100 of the bootstrapped ones were lower. So these meet the criterion at 95% and also at 90%. You could go back, if you went back to the linear, to the upload actually, you could look and find those particular paths, but that's more or less beside the point. Okay, so already in groups 1 and 2 we have a difference. We can see also that there's, if we look at the difference between groups 1 and 3, there is none at the 95%. If we look at the difference between 2 and 3, here, again, those 2 were different. Enjoyment in this case was very high. A 0, it goes from 0, how many were, this would be how many were greater. None of them were greater. In the other case, 1 was greater, so I may have misspoke. None of them were greater. In this case, we had a difference of minus 32. How many were greater? All of them. All 100 were greater. So these two differences are both very extreme. So there's a group effect between groups 2 and 3 for the path, the direct effect from perceived usefulness to attitude, and for trust to attitude. Okay, so that's that. Now, the rest of the question, so we saw differences between groups 1 and 2 and between 1 and 3. The rest of the question, between groups 1 and 2 and between groups 2 and 3, we saw differences. The rest of the question asks about measurement invariance. It asks about configural invariance, metric invariance, and scalar. Well, configural invariance just simply means, do you use the same indicators on the instrument for the tests? Do you use the same survey items for the groups that are different? And we do, so that's a no by default. There's no configural invariance because we're using the exact same measurement blocks, the same measurement scales for each one, measurement models. Metric invariance means, are the weights and loadings significantly different? And we answer that question. Let's just do one of them for time. So here, the direct paths between 2 and 3 are significantly different for this one and this one. So we need to go over and we need to look at the weights and loadings at a minimum for those constructs, at a minimum for enjoyment, attitude, trust, and attitude. Now, others would say you need to look at the weights and loadings for all of the constructs. It doesn't matter which particular constructs are different, but that's another question. Okay, so loadings, we look at loadings, enjoyment, attitude, trust, and attitude. And we can kind of, here's enjoyment. We see none of the enjoyments are different. Trust, 2 of them are different. And then attitude, I can see the bottom. You can't. None of them are different for attitude. Now, so we had 2 out of 12 that were different for the loadings. Let's look at the weights. Here's the weights. We see again, there's 1 for enjoyment that is significantly different between the 2 groups. Then several for trust, all of them actually significantly different. This is a problem. This indicates measurement invariance. The measurement scales are not the same. You're not looking at a group effect necessarily. You're looking at the fact that they read the questions differently. Not that they're responding to the same understanding of the question differently, but rather that their interpretations of the questions are different. That's not a group effect. That's an understanding effect. Okay, so the answer to this part of the question is there metric invariance. In the first case, it was partial. The second case, there were quite a few that were different, so that might be a problem. We would have to say yes. Scalar invariance really relates to the latent variables. Are they different between the groups? And we have that as well. All we have to do is, for each of in the 7 reports, we have 2 reports that relate to the latent variables. One relates to R squared. So the R squared values, we look, attitude, trust, enjoyment. This one is not different between 2 and 3 for the R squared. The latent variable scores, however, trust is significantly different between groups 2 and 3. And then if we went back to groups 1 and 3 and looked at the same thing, latent variable scores here, 1 and 3, they are invariant. They're scalar invariance. Scalar means the nature of the latent variable in the 2 groups. And you can look at the means, you can look at the variance, you can look at the R squareds. Any measurement structure or structural property of the latent variable is fair game to compare. If the latent variables are different, again, you're not comparing the same thing between the two groups. It's different. So it might not be a group effect. It might be something else. And so there's latent variables for group 1 and 3. Here's R squared. We do have significant differences in R squared. So the answer to these would be, is there configural invariance? Yes. They are invariant as far as the particular items on the questions. The measurement items on the questions that were given to both groups are the same. They are invariant. Is there metric invariance? Means the weights and loadings for the groups that were different, are the weights and loadings the same or not? And half were and half were. We had partial metric invariance, which in some cases is acceptable. You'd have to refer to the literature. Do we have scalar invariance? Well, that relates to the structure of the latent variables, and we did find many violations of scalar invariance. So the answer to that would be probably not. They are not invariant. So that's the answer to that question.